Remote sensing and satellite imagery for wildfire detection. Image acquisition and processing techniques play a crucial role in remote sensing and satellite imagery for wildfire detection. In this tutorial, we will explore the various techniques used to acquire and process images for this purpose. By understanding these techniques, you will be able to effectively analyze satellite imagery to detect wildfires. Satellite image acquisition techniques. Multispectral imaging. Multispectral sensors capture images in multiple bands of the electromagnetic spectrum. Different sensors can capture various combinations of bands, such as visible, near-infrared, short-wave infrared, and thermal infrared. These bands are essential for analyzing vegetation health, identifying hotspots, and detecting wildfires. Thermal imaging. Thermal sensors capture the thermal radiation emitted by objects. These sensors measure the temperature of the Earth's surface and can help identify fire fronts and hotspots accurately. Synthetic aperture radar, SAR. SAR sensors transmit microwave pulses and measure the reflection or scattering of these pulses. SAR images are especially useful for detecting wildfires during nighttime and cloudy conditions, as they are not dependent on sunlight. Geostationary satellite systems. Geostationary satellites, such as GOES, Geostationary Operational Environmental Satellite, and Himawari, provide continuous monitoring of large areas by capturing images at fixed intervals. They are particularly effective for capturing images of active wildfires and tracking their progression over time. Image pre-processing techniques. Radiometric calibration. Radiometric calibration ensures that images captured by different sensors are standardized and can be compared accurately. It involves correcting for sensor-specific variations in terms of brightness or radiance. Atmospheric correction. Atmospheric correction compensates for the interference caused by the Earth's atmosphere during the image acquisition process. By removing atmospheric effects, such as scattering and absorption, the true surface reflectance can be derived. Geometric correction. Geometric correction corrects for distortions introduced during the image acquisition process. It involves aligning the satellite imagery with ground control points to obtain accurate spatial representation. Image enhancement. Image enhancement techniques, such as contrast stretching and histogram equalization, improve the visual quality of satellite images. These techniques enhance the visibility of features related to wildfires, aiding their detection. Image processing techniques. Fire detection algorithms. Various algorithms, such as the Normalized Fire Index, NFI, and the Difference Normalized Burn Ratio, DNBR, are employed to detect and monitor wildfires. These algorithms analyze specific spectral bands and quantify the presence and extent of active fires. Change detection. Change detection techniques compare multiple images taken at different times to identify significant changes, such as the appearance of new fires or the expansion of existing ones. Classification techniques. Classification techniques, like supervised and unsupervised classification, are used to categorize different land cover types. Assigning specific classes to fire-affected areas can assist in understanding the extent and severity of wildfires. Post-processing techniques. Fire severity assessment. Post-processing techniques, such as the calculation of burn severity indices, provide information about the severity of a fire's impact on the landscape. These indices quantify changes in vegetation health and burn severity, aiding in post-fire analysis. Spatial analysis. Spatial analysis techniques, including overlay analysis and buffering, help analyze the spatial relationship between wildfires and relevant features, such as vegetation density or proximity to human settlements. These techniques can assist in identifying high-risk areas for future wildfire occurrences. By familiarizing yourself with image acquisition and processing techniques, you will be well equipped to effectively analyze satellite imagery for wildfire detection and monitoring. These techniques, when combined with the principles of remote sensing and satellite imagery, enable early detection and response, contributing to effective wildfire management and mitigation efforts.